All right. Hey guys, this is Algebra 2 4.5. This is going to be part 2. You could call this condensing and expanding. Um so expanding, we'll do expanding first though, okay? So you could label this expanding in your notes. All right. So expansion. What does that mean? That means we're going to use the rules that we learned from last time. And just a reminder what the rules are, and I'll keep them up here. If they are multiplied together, you could rewrite them as added separately. If they're divided together, you could write them as subtraction separately. And if there's a power to a power, so log m to the n power, you can move the power into the front. Okay? So those are the rules, all right, that we went over yesterday. So today's lesson is going to be focused on two parts. One is expanding and one is contrasting. Notice here, we're not getting an actual answer. We're just rewriting this. So there's no, the final answer, you could kind of call this a simplification. But sometimes we need to simplify outwards. Sometimes we need to simplify inwards. So today, expanding, you could guess, is going to be simplified outwards. So here's a couple of example problems. Let's take log 3 to the x. And my instructions to you is to expand this. Well, I see 3 times x is happening right here, okay? So 3 times x is happening right here. So to expand it, I'm going to spread it out as 2 separate logs. So I want as many logs as possible. So since they're being multiplied, I'm going to rewrite them as addition. So it's going to be log 3 plus log x. Okay? Log 3 plus log x. Now, since log 3 is all by itself in the log, that one's good. Since x is all by itself in the log, that is good. Since everything has its own log, we are done with that one. So if they're multiplied together, you can spread them up with addition. Let's do another example. Log base 2 6x divided by 2. Okay? So there's going to be a lot happening in this one, so pay attention. So first off, I see a big division. It's going to be easier to separate the division first. So what I'm going to do is rewrite it as log base 2 6x. Oh, and important, if it was a base 2, everything you separate has to be a base 2. If it doesn't show a base, you don't have to show a base, okay? So log base 2 6x. Remember, division causes to subtract. So I'm going to put a minus sign. Log base 2, 2. Now, let me check. This one right here, 2 is all by itself within this log, so we're happy. But this one right here, 6 and x are still together. And because 6 and x is still together, I need to still separate this. Now, 6 times x is happening, so I can separate it with a plus. So log 2, 6 plus log 2, little 2, base 2, x. Don't forget this guy, minus log base 2, 2. So that's for this line. 6 is by itself in the log, that is good. When x is by itself in the log, that is good. Log base 2, 2, it's by itself, that is good. There's just one thing, one little extra thing. Log base 2, 6, well, that's not clean. Log base 2x, that's not clean. But log base 2, 2. Wait a second, if you remember from our last section, these are matching. So what happens when they're exactly matching? They cancel out to 1. So my final answer, log base 2, 6 plus log base 2x minus, this completely cancels out to 1. So my final, most simplified answer is log base 2, 6 plus log base 2x minus 1. I'm going to do at least one or two more of this examples. All right, let's continue. We got log x over 3y. All right. So I see a big division, so let me spread that out first. Again, we're expanding here. So we get log x minus log 3y. Wait a second, log x is by itself, so we're really happy with this part right here. But log 3y is not by itself yet. So what we're going to do is rewrite this aspect, and I'm going to use parentheses here because this is getting minus, so I just want to show that everything's minus here. I'm going to separate this as log 3 plus log y. And I'm allowed to do that because they're being multiplied. When they're multiplied together, you could add them separately with a log x here. And let me just distribute this negative to everything. Log x minus log 3 minus log y. Okay? Every single one is by itself. There's no cancel outable, right? It's a divisible 10 on the bottom, but none of them are 10, so we can't cancel anything out. So from this point, since everything has its own log, it is fully expanded. So that is considered expanded. All right. Let's do one more problem. I'm going to make this up on the fly, so hopefully it works out. Let me just pause and then reset. Okay, our last one. Log x to the third power, y to the second power. So the first thing I see is x to the third power times x to the second power are being multiplied. So since they're being multiplied, I can separate them with adding. So that becomes log x to the third power plus log y to the second power. X is not by itself. It still has this power 3 up here. So from my rule, if I have a power in the log, I can move it in front. So I'm going to take this 3 and move it in front. And I'm going to take this 2 and move it in front. So my final answer is going to be 3 log x plus 2 log y. X is all by itself in the log. Y is all by itself in the log. Everyone has their own log. We are happy. So we can box this. This is a fully expanded log. So this video is going to cover expanding. And I said I believe I'm going to do contrasting also. So let me erase this and let's do a contrast problem. All right. So I think I just said contrast in the last section. It should be condense. So let's do a condensed problem. So it's basically the reverse of expanding. We're going to have two separate logs and reduce it all into one log. Or how many logs it takes. So let's do one, a simple one. Let's do log 7 plus log 3. Okay, they're separate logs with a plus sign in the between. Because they're separate logs in the plus sign in between, we can do the opposite of over here. From over here, we said when they're multiplied together, they're added separately. So we could do the converse, which is if they're added separately, they're multiplied together. So when I ask you to condense, and I should put up here, this is the condensed part, we're putting them together. So log 7 over plus log 3 is going to condense into 7 times 3. Now, I could actually do the math of 7 times 3. So I'm going to rewrite that as log 21. This is single log. In the expand, we want everyone to have their own log. In condense, we want everyone in one log. So this is one log. We're good. We're going to circle or box it out. That is done for that question. Let's try another. A little bit harder. So let's do. Oop, don't want this to fall over. 2. Let's do log x plus. No, let's do minus to mix it up. Minus log 11. Okay? So for this one, I have a number in front of a log. Number being multiplied with a log. So what that allows me to do is take this number and put it on top of the x. So now I have log x squared minus log 11. Now I have two separate logs that are being subtracted. I could combine that by doing one division. So it's going to be log x squared divided by 11. Over here, I don't know what x squared divided by 11 is, so this is as simple as possible. So I box it off, and I am done with that question. Let's do two more condensed. Okay, so let's do another set. This is going to be 5 ln y plus 3 ln x. And then I'm going to do another one, 3 log 2 plus 4 log x minus log y. Okay, I'm going to do both of these and then the end of our video. All right, so let's do the top one. So 5 ln y plus 3 ln x. We're going to do that one. So the first thing we're going to do is put the 5 up here, and we're going to put the 3 up here. So now we have ln y to the 5th plus ln 3x to the 3rd. Because there's a plus sign in between, I can combine them to a multiplication. So it becomes ln y to the 5th x to the 3rd. I don't know what y 5th x to the 3rd is, so that's as simple as possible. So I could box it off. All right, last one. Now there's 3 parts. That's okay. We could condense to 3 parts. Let's first move any exponents up to the top. So let's move 3 up here, and let's move 4 up here. This one doesn't have it, so that's okay. So we got log 2 to the 3rd power plus log x to the 4th power minus log y. First off, I could do what 2 to the 3rd power is. I actually know what that is, so I'm going to rewrite that as 8, okay? Now I'm going to combine these two logs right here. So I have log 8 times x to the 4th minus log y. Let's continue. This is a minus. When you minus, you divide. So now it's going to be log 8x to the 4th divided by y. I can't do any of the math here because I don't know what x and y is. So this is simple as possible. I've heard from previous classes that condensing and expanding is one of the harder parts of logs. So I'm just going to put a little bit of homework and a little bit of practice, and I'll have a Zoom for later today to practice. All right, have a wonderful day.